So, in the last class we were discussing if xt is a random process, then yt is the output of a linear time invariant system with impulse response h of t, transfer function h of j omega. We found out that syy omega is equal to hj omega square into sxx omega. Right? We also have found, or try to find at the end of the class, expected value of xt plus tau yt, that is the cross correlation between input and the output, is equal to expected value of xt plus tau integral minus infinity h alpha x right by definition. So, the expectation is to be taken on this product here. In this is random process, this is random process, H is deterministic, that was the assumption we made, the deterministic system. Then this result will come out to be integral minus into plus infinity h alpha into rxx tau minus alpha. Right? Because this is x is supposed to be WSS process. So, this expectation will be difference between the two times, which is equal to t plus tau minus t minus tau, which is equal to t minus t plus alpha. It doesn't matter because now if the input xt is white noise, we discussed the property of the white noise, that white noise has a spectrum which is constant from minus infinity to plus infinity. So, the Rxx tau for the white noise is equal to sigma x square into u0 tau. So, the Fourier transform of that, which happens to be the power spectral density, is a constant value of the height equal to sigma x square. This obviously is the idealization. Such process does not exist because this implies infinite amount of power, because integrated Sx as integrated value of right. So, this value will be infinity because there is a constant value integrated from minus process. So, such a process is not physically realizable process, but we do some idealization assuming such a process exists which has a constant value from minus infinity to plus infinity. This is not a unreasonable thing to do, because at the end of the day the system will limit the bandwidth. So, the power becomes automatically a finite value of power. So, making an assumption that the input is a Whiteson stationary white noise process as a theoretical investigation is not an unreasonable thing to do. If that is the property of this WSS, that is also white, if it is white, and then this will become equal to Hj omega square into sigma x square, right. So, this white noise which has theoretically infinite bandwidth will get modified by this linear time invariant system, and the new power spectral density is equal to the same constant multiplied by Hj omega square. So, this linear time invariant system will modify the spectral density of the input white noise into a different spectral density depending upon the transfer function of Hj omega. And such a noise which has a non-white property is known as a colored noise. The words are borrowed from optics. White light is supposed to contain all frequencies from 1 to the plus very large bandwidth with constant value. So, we call that white noise, and any colored noise, any color, we are supposed to have some spectral variation. So, we call this a colored noise. Sometimes they also call this pink noise. These are languages, terms that people use. Now, if this is the situation here, same as there, that this is a white noise, and then this integral will become equal to okay. And what is that integral equal to? Integration variable is alpha. So, whenever this is equal to 0, you evaluate this at this point. So, this will become equal to sigma x square into h minus tau. Okay. So, if I make this minus tau here, this will become minus here, so this will become a plus. Correct. It is a very powerful result. In this sense, if I want to know the impulse response of a linear time invariant system, one method is to apply white noise as the input and find the output of the system and cross correlate these two and evaluate this integral cross correlation for shifted values of the input function x of t. It implies is just take this dabba, delay by a tau, yt xt minus tau and integrate it. So, you will get the value equal to h alpha, h tau.